SpaceX launches 50th Falcon 9 orbits bus-sized Spanish communications satellite Hispasat 30W6.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Pitching downrange.
Stable, launch terminal.
In the early morning hours of March 6, 2018, SpaceX launched its 50th Falcon 9 rocket since it debuted in 2010. This flight saw the delivery of the Spanish Hispasat 30W6 communications satellite into a geostationary transfer orbit. This was the fifth flight of a SpaceX booster since the start of the year, including the long-awaited first maiden launch of the company's Falcon Heavy. Liftoff of the Hispasat 30W6 satellite took place at 12:33 a.m. Eastern Standard Time, 5:33 Greenwich Mean Time, right at the opening of a 2-hour launch window from Cape Canaveral Air Force Station's Space Launch Complex 40. Hispasat 30W6 is a telecommunications satellite built on the SSL 1300 satellite platform. It will ultimately reside at 30 degrees west in geostationary orbit, serving as a replacement for Hispasat 30W4. It provides television, broadband, corporate networks and other communication services, according to SpaceX's press kit on the mission. Its solar panels will power 40 Ku-band transponders, 6 Ka-band beams and 10 C-band transponders over an expected lifespan of about 15 years. From its spot in geostationary orbit, the 13,430-pound, 6,090-kilogram satellite will provide coverage to 2 areas, according to Hispasat, the company operating the satellite. The first area will be Europe and North Africa, specifically with coverage on the Iberian Peninsula, the Balearic Islands, the Canary Islands, the Azores, Cape Verde and Madeira. Mauritius, Morocco, Mediterranean countries in northwest Africa and a large part of the European continent. The second area will be the Americas from Canada to Patagonia, not including Brazil. SpaceX performed its customary static fire test on the vehicle back on February 20, 2018, and were initially targeting February 25 for launch. However, 2 days before the attempt, the company announced it was postponing the flight to conduct additional testing on the fairing's pressurization system, and that once completed, pending range availability, it would confirm a new target date. The March 6 date was ultimately chosen. Weather conditions were predicted to be 90% favorable during the 2-hour-long window. About 70 minutes before the planned liftoff, the company began loading rocket-grade kerosene, also known as RP-1, into both the first and second stage of the rocket. This was followed 35 minutes later by liquid oxygen. Throughout the countdown, things continued nominally and quietly up until about 7 minutes before launch. That was when the 9 Merlin 1D engines on the first stage of the Falcon 9 began conditioning before launch. Then about a minute before liftoff, the flight computer was commanded to begin final pre-launch checks, ensuring all was well with the rocket. At the same time, the propellant tanks began to pressurize, as planned. 3 seconds before the countdown reached 0, the 9 Merlin 1D engines ignited and spooled up to full power. At 0, the launch mount released the vehicle and it began its ascent toward the black of space, providing a brief midnight sunrise for those residing along Florida's Space Coast. 1 minute, 18 seconds after liftoff, the vehicle reached max Q, the point where aerodynamic stresses on the vehicle are at the highest. Just over a minute after that, the first stage finished its job in powering Hispasat 30W6 towards space, and its 9 engines cut off. 2 seconds later, the first and second stages separated. Then at 2 minutes 39 seconds into the flight, the second stage's single Merlin vacuum engine ignited to continue pressing toward orbit. While many may have become accustomed to seeing SpaceX recover the first stage boosters either on a ground pad at the Cape or a drone ship downrange at sea, for this flight the company opted to not recover the stage. Despite the fact that his Parsat 30W6 is the largest geostationary satellite it has flown at 6 metric tons, according to a tweet by company founder and CEO Elon Musk, the company did have plans to attempt a recovery. However, according to SpaceX's webcast, 26-foot 8-meter waves were expected to be too much for the drone ship. As such, it remained at Port Canaveral. Regardless, the first stage, still sporting titanium grid fins and landing legs, did perform its various burns for a landing. But instead of a drone ship landing, it was a splashdown that ultimately destroyed the stage. Meanwhile, the second stage with his Parsat 30W6 continued on its way to a low Earth parking orbit. A minute after stage separation, the vehicle and payload were high enough in the atmosphere that drag was no longer a factor. As such, the protective payload fairing at the top of the rocket fell away as planned. After about 6 minutes, the second stage's lone engine cut off. For the next 18 minutes, the stage and payload coasted around the planet waiting for the right alignment to perform a second burn to place his Parsat 30W6 into a geostationary transfer orbit. That 1-minute burn came some 26 minutes 38 seconds after leaving Florida.
Some 5 minutes after that, his Parsat 30W6 was deployed.
Over the coming days and months, the satellite will use his onboard engines to circularize its orbit at 35,800 kilometers over the equator. As stated above, the March 6 flight marked the 50th flight of a Falcon 9. It was also the 4th overall and the 3rd to fly from SLC-40 in 2018. SpaceX is off to a fast start in terms of launches as it aims to beat its record of 18 from 2017. The next flight is currently slated for March 29th and will see a previously flown Falcon 9 send 10 Iridium NEXT satellites into space for Iridium communications. With 3 operational launch pads on 2 coasts, SpaceX could see as many as 5 Falcon 9 rockets sent spaceward in April alone. Also upcoming for 2018, should no delays occur, is the first flight of a Block 5 Falcon 9 with numerous upgrades in its design meant to provide the rocket with greater reliability and reusability. At present, this launch is planned for April. Following that should be the first operational flight of a Falcon Heavy in June and the first test flight of a Crew Dragon uncrewed as early as August.